Hi guys, this is a video on finding missing side lengths of similar triangles. So this is Unit 6, Topic 5. The key to these problems is identifying which angles are corresponding to each other. And the way that we do that varies in each problem, but that's important because that's how we're going to set up our similarity statement. We have to know what angles are congruent to each other, so we know what angles are corresponding to each other so that we can set up our similarity statement. So the first option is I just flat out give you a similarity statement. So for example, I tell you that triangle ABC is similar to triangle DEF, and therefore you know what your correspondence is. A corresponds with D, B with E, C with F. You can write your scale factors, or you can write your congruent angles and move on. The second option is that I give you parallel lines in the problem. So in this diagram, I give you some parallel lines, and if these lines are parallel, then I know that I will have congruent corresponding angles. And just to remind yourself what corresponding angles look like, they are, again, the angles that are in the same location, meaning at this intersection, this is in the top left, at this intersection, top left. So if I slide these four angles down on top of these four angles, this angle lands on this angle. So I have corresponding angles in this diagram. Angle ABC is corresponding to angle ADE, so those angles are congruent. I also have corresponding angles ACB and AED. I also know that angle A is congruent to itself by the reflexive property. So now that I have all of my sets of angles marked congruent, I can write my similarity statement. So I have triangle. The first triangle, I don't care which triangle you start with. I don't care what order you name it in. Just pick a triangle to start with. I'm going to start with a smaller one, ABC. And then I just choose my correspondence from here. I know A corresponds with A because it's marked congruent to itself. B corresponds with D. And C corresponds with E. So there's my similarity statement. So now I can write my congruent angles or equal scale factors. In this diagram, I have alternate interior angles. So as a reminder, your alternate interior angles, one is on one side of the transversal, one is on the other. They're both inside of the parallel lines. So I have alternate interior angles U and R are congruent to each other, and they're congruent because the lines are parallel. Q and T. And I know that angle QSR is congruent to angle UST because they are vertical angles. So now again, I can write my similarity statement easily. I have triangle. I'm going to start with this triangle here, QRS, similar to triangle. Q corresponds with T, R corresponds to U, and S corresponds to S. Now I have my similarity statement. Now I can move on with the problem. The next option is that I give you congruent angles. So for example, in the given, I might tell you that angle NOP is congruent to angle L. Okay? Now in this problem, these lines, first of all, I didn't tell you that they're parallel, and they definitely don't even look parallel. So what's happening here is that I'm not just having a dilation, but this triangle, in addition to being dilated, is also being reflected. So I don't have O and M corresponding and N and L corresponding because my lines are not parallel. That's why I have to give you some congruent angles in the problem. So if I mark these angles, I have angle L congruent to angle NOP, that's this angle. I know angle P is congruent to itself by the reflexive property. And then that leaves only one angle in the smaller triangle, 1, 2, 3, to go with one angle in the bigger triangle. If I can show that two angles in two triangles are congruent, the third set of angles have to also be congruent to each other. So now my similarity statement, I'm going to start with triangle LMP. It will be similar to triangle. So L corresponds to O, M corresponds with N, and P corresponds with P. Okay, so there's my similarity statement. I can move on to the rest of the problem. The final option is that I'm giving you midpoints and or congruent segments to get midpoints. So in this first example here, I know that E is a midpoint because these two parts are marked congruent, and I know F is a midpoint because these two parts are congruent. So I know that segment EF is called a mid-segment. If that's true, then one of the things that I know about the mid-segment is that I'm parallel to this third side of the triangle. And if they're parallel, I'm back to my example over here where I was given parallel lines. I have congruent corresponding angles. And angle D is congruent to itself by the reflexive property. So here, once again, I can set up my similarity statement. Triangle DEF is similar to triangle. D corresponds with D, E corresponds with G, F corresponds with H. Okay? Here I have the same idea. I know that X is a midpoint because I didn't mark them congruent, but I told you they had equal lengths. If 3 and 3 are the lengths of these two segments, they are congruent to each other. And so similarly, Y is a midpoint because 5 and 5 are the same length. These are congruent to each other. Again, if I have two midpoints, I have a midsegment, and I know a midsegment is parallel to the third side of the triangle. Parallel lines give me congruent corresponding angles. And then I have my reflexive angle. So I have triangle WXY, similar to triangle W corresponds with W, X corresponds with Z, Y corresponds with V.